welcome to an introduction of factoring difference of squares. So to recall, we have a plus b and a minus b. What we want to do is we want to expand that. So if I were to expand that, it would be a times a, which is going to be a squared, and then a times negative b, which would be minus ab. B times a is going to be plus ab, and b times negative b will be minus b squared. And if I were to simplify what's here, remember these are like terms, minus ab plus ab, this is going to sum to 0 and they cancel each other out. So what we're left with is the title of today's lesson, which is the difference of squares. Difference of squares, short form DOS, is right here. This is considered a difference of squares because this is a subtraction between two perfect squares. So for it to be a difference of squares, there needs to be subtraction. Oopsies, let's get a thicker pen. So it needs to be subtraction and two terms only. Okay, so there's only two terms here, and they need to be perfect squares. Each term is a perfect square. Okay, so right here, as you can see, these four look to be difference of squares because they all have subtraction. So let's highlight subtraction here. They're all subtraction, so these are all differences. That's what difference means, subtraction. And they all are perfect squares. X squared is perfect, 100 is perfect because those are perfect squares. 9 is a perfect square, a squared is a perfect square, 36 is a perfect square, b squared is a perfect square. I don't know about these. These don't look like perfect squares. We'll have to check with something else. 16 is a perfect square, m squared is a perfect square, and even 1 is a perfect square. So they're all perfect squares. And they all have two terms? Yeah, two terms, two terms, two terms, two terms. So each of these are considered difference of squares. Well, we'll have to take a look at C in a little bit. Okay? So let's go ahead and try to factor these difference of squares. Now, factoring requires that we are given this, this expression, and we need to find and convert it back into this form where it's multiplying. That's what factoring is, breaking something into two factors. So, and to do that, you can see that a squared, to go back into this form, you just basically take the square root. A squared, the square disappears. That means to go back to a, you take the square root of each. So you take the square root of x squared. What is the square root of that? That's going to be x, right? We want to, again, set up those binomials like we've done normally. X times x gives us that x squared. 100, what two numbers multiply to 100? And is a square root of that. Well, the square root of 100 is just 10. And this is also 10. Now, there is no middle term. If you want to write it, pretend there's like a 0x in the middle. These two middle terms are canceled out because these are going to be opposite signs. So if you want to check, you can expand this, and you'll see that it does, in fact, become the original question. Okay, so you just take the square root. That's the fastest way of doing it. So here, we take the square root of this. What's the square root of 9? Ooh, that's 3. Square root of a squared is just going to be a. And so we can set it up. 3a times 3a gives us 9a squared. 36b squared, what's the square root of 36? 6. Square root of b squared? B. And again, because it's a perfect square, we can know that the other side of the bracket will be also 6b, because 6b times 6b will give us that 36b squared. And because there's only two terms, right, that middle term will get canceled out, so that's going to be plus and minus. Now this one, if you check in your calculator, or if you know your numeracy skills your number fluency is very high, you would know that those are not perfect squares. You take the square root of each, and it's not going to be a whole number. Now remember, there's always one type of factor you should always check first. It's common factoring. So always check common factoring first. In this case, is there a number that goes into both 98 and 162? It's kind of hard for me right now, but I know that 8 itself is an even number and 2 itself is an even number. So I'm looking at the last digit for each. That means it's divisible by 2 at the very least. So I'm going to divide by 2 and make the numbers a little bit smaller and see if there's anything else we can factor out later on. So 98 divided by 2 is going to be 49. We didn't factor out any m, so that m to the power of 4 will remain. 162 divided by 2 is going to be 81. And now these numbers look a little bit more familiar for me. I know that 49 is a perfect square, M4 is also a perfect square, and 81 is also a perfect square. And again, it is considered a difference, I'm doing it in blue, of two perfect squares. 49 is a perfect square, m to the power 4 is perfect square, and 81 is a perfect square. All right, so let's factor it out. So 49 is a perfect square, we know it's 7 and 7. M to the power 4 is what two numbers would multiply to m to the power 4? Well, square root of that is going to be m squared times m squared, right? And if I were to check that, if I expand this portion out, 7m squared times 7m squared gives us 49m to the power of 4. 81 here is going to be, what two numbers multiply 81? Take the square root of that, it's going to be 9 and 9. And again, since there's no middle term here, it got canceled out. That means that these two signs are opposite. And that's it. Okay, so we have fully factored this one, which is what this implies. There might be multiple types of factoring that you might have to do. So always try to common factor first, make the numbers smaller and easier for you to recognize that these are perfect squares, and then do your difference of squares factoring from there. And the last one, part D, 16m to the power 4 minus 1. So what we're going to do is we are, again, this is considered a difference of squares based on what we described here. So I'm going to set up my two binomials and find the square root of each of them. So 16m, the square root of 16 is going to be 4 and 4, because 4 times 4 will give me 16. M to the power of 4 is m squared. This is m squared. And 1 is also a perfect square. People tend to always forget this one. But yeah, 1 times 1 is 1. So 1 and 1 will give us 1. So that's a perfect square as well. And again, because there's no middle term, they get cancelled out because these signs are opposite. Now, most people would stop here because, oh, we've done difference of squares once. But again, because of this key term here, factor fully, you should always double check to see if you can factor further. Here, I take a look at this. Let me get that thicker pen. Here, I take a look at this. This is two terms. So it looks like it's difference of squares because this is a perfect square, this is a perfect square, this is a perfect square as well. But this is not a difference of squares. This is called a sum of squares, and you cannot factor that. So we leave it alone. But here, right here, 4 is a perfect square, m squared is a perfect square, 1 is a perfect square, and this is a difference of two perfect squares. So we can actually do the same thing here and break this up into its own set of brackets, two set of binomials. Square root of 4 is going to be 2. Square root of m squared is going to be m. And check. If I were to multiply this out, 2m times 2m, does that give me 4m squared? Yes, it does. Square root of 1, it's going to be 1. This is also going to be 1. And again, there's no middle term, it's going to be plus and minus. And let's double check. Can we factor anything else? No, there's nothing in common, no common factoring, no other difference of squares, because these are no longer perfect squares. 2 is not a perfect square. M is no longer a perfect square. M squared is a perfect square, m to the power of 4 was a perfect square, but m itself is not a perfect square. Okay, so there you have it. This is how you factor something with using difference of squares.